All right, example 2, we want to graph the function f of x equals 2 times the sine of x. We want to find the amplitude in the period. So amplitude is always based upon the number being multiplied in front of the trig function. So the amplitude is 2 here. Period is always 2 pi divided by b, and b is always the number in front of x here inside the function itself, which is just 1 in this case. So the period is 2 pi. Because the amplitude is 2, that means instead of being bounded between -1 and +1, it's going to be double that, so -2 and +2. So I'm going to make that -2 and +2. Okay. And again, I like to draw in these boundaries for the upper and lower bounds of these graphs just to visually make sure that I'm not going outside of those. Now from here, normally sine at 0 is at 0, 0, and we're still going to have that point here. Now traditionally, and actually what I'm going to do for you right now is I'm going to graph the original parent function. Okay, so what I'm graphing right now is not the new function, the 2 times the sine of x. I'm just going to graph the original sine of x function, just so you can kind of see how they compare. So in the original sine of x function, at pi over 2 we're at 1, at pi we're at 0, 3 pi over 2 we're at -1, and 2 pi we're at 0. So this is our one cycle of the normal sine graph, no transformations. What we're going to do is take this graph, and the only thing that is changing is this amplitude of 2. So my points that are on the x-axis are going to stay there, but all my highs and low points are going to be stretched to meet that amplitude, like so. And then if I mimic that on the other side, that means at -pi over 2 I'll be at -2, -pi is 0, -3 pi over 2 is 2, and -2 pi is 0 as well. And there we are. So you can use the original function and transform the points of the original function as well to get your new transformed function. All right, so now let's take a look at example 3. We have, let's see here, this one. We actually want to do not the sine of x minus pi over 4, but cosine. We've done 2 sine functions, so let's switch to cosine. Identifying the amplitude here. The amplitude is what's being multiplied in front of the trig function, which in this case is just 1. And then identifying the period. Period is the number, it's 2 pi divided by b, which b is what's being multiplied in front of x. In this case, x is not being multiplied by anything, so the period is just 2 pi. Now, we do have this -4 happening, or minus pi over 4 happening, and what that is actually doing is it's shifting the whole graph pi over 4 units. So what I'm going to do first is graph the original cosine function, and then I'm going to show you how we can transform that. So graphing the original parent cosine function, I'm going to do it in orange. I'll do it in pink. So the normal traditional cosine function, which if we look back at where we originally defined it in our notes, or if you refer to your copy here, if you have one off to the side, we have a point at 0, 1, and at pi over 2 we are at 0, at pi we're at 1, 3 pi over 2 we're at 0, and at 2 pi we're at 1 again. So that's one cycle of the original cosine function. Again, being bounded by positive and -1, as that is what the amplitude is. What's going to happen now is we're going to take that and we're pushing all of these units forward pi over 4 units. Pi over 4 is what's in between all of these pi over 2's and the next tick mark, okay, because it's like 1/4, which is half of a half. So this point that was originally at 0, 1 is now going to get pushed forward, okay, pi over 4 units. So it's going to go right there. Then the next function is also going to get pushed forward pi over, or the next point is going to get pushed forward pi over 4 units, so right there. And then I'm just going to continue moving all of these points as far as I can. There technically would be something like here, right? And this is what I end up with. So everything is the same, but it's off by pi over 4 units. And if I continue that, and if it's helpful to look at it by graphing or looking at the original cosine function, I just think that sometimes that's a nice visual for us to see exactly what points we're moving. The one that was at negative pi over 2, 0 is now going to be at negative pi over 4, 0. The one that was at negative pi, negative 1 is now going to be at negative 3 pi over 4. And we're going to move the one at negative 3 pi over 2 forward and the one at negative 2 pi. There we are. And that is the graph of cosine of x minus pi over 4, where we've taken the whole graph and we have shifted it forward pi over 4 units. Examples 4 and 5 are not wanting us to graph the function, but instead to take our knowledge of amplitude and period and be able to write a function that's been graphed. There are technically a variety of answers you could go off of, but I would rather us just not make it too complicated and really utilize where the graph is crossing the y-axis to determine what type of function it is. So this graph is crossing the y-axis at 1, and that matches the characteristic of our cosine functions. So I know I'm going to be dealing with a cosine function here. The next thing I'm going to do is I'm going to look at what is the length of one cycle before it goes on repeat. And if I were to trace this, it's here. So that is going from 0 all the way to pi. So the length of one cycle before the graph goes on repeat is pi units long. Now remember, period is normally calculated (2 pi over the absolute value of b. Well, we know the length of a cycle is pi units. So we can set up this equation and be able to solve for b. So I'm going to multiply b over and have b times pi equals 2 pi. Divide by pi to get b by itself. And end up with b equaling 2. So that means inside my parentheses here being multiplied by x is going to be 2. After that, I need to figure out, okay, what is my amplitude? Amplitude is looking at kind of like our boundaries, right? These numbers that we're kind of ping-ponging in between. This is crossing the y-axis at negative 1.5 because this is negative 1, so another tick mark would be 1.5 to positive 1.5. So notice that the distance here, from the x-axis, which is kind of like this, the line that divides this graph in half horizontally, the distance from the x-axis to the top of the graph is 1.5 units, or in other words, you could say 3/2. So our equation is going to be y equals 3/2 times the cosine of 2x. All right, pause the video and give example 5 a try on your own, and then press play to see the answer. Creating the equation for the graph below, if I were to go through and kind of highlight one cycle of this, you will notice that it starts at 0, 0, and then it's going up until 4 pi. This is 4 pi, because pi is 1 tick mark, and we have a total of 4 tick marks happening here. So I know that 1, this is going to be sine, because it's going through the origin, and 2, the length of the period is 4 pi. So I'm going to use that to then find what b is. Multiplying b over, and then dividing by 4 pi. You might have been able to figure this out without doing this very algebra math, but in case you like the procedure of it, this could be helpful for you. So we get b equal to 1/2. So right off the bat, I know I'm going to end up with a y equals, and then sine of 1/2 x. After that, I need to identify the amplitude. So what is my range of motion that this wave is bouncing between? From the x-axis to the top of the graph is a distance of 1/2, and so that's my amplitude. And that's example 5.